So concept of resistivity. So we have here a wire, and let's say the length of the wire is L1 and R1 is the resistance of this wire, for example, like this. There's another wire which has the same cross-sectional area, but the length is greater. The area of cross-section is the same. So this is the area of cross-section here, and this is also the area of cross-section. And the resistance is R2, and the length is L2. ठीक है जी, आपके पास रेजिस्टेंस R1 है, यहाँ पर रेजिस्टेंस R2 है, इसकी लेंथ L1 है, इसकी लेंथ L2 है. Both wires have the same cross sectional area. You should know that कि जितनी ज्यादा लेंथ ज्यादा होगी कंडक्टर की, उतना ज्यादा इलेक्ट्रॉन्स के फ्लो को मूव करना मुश्किल होगा, राइट? ठीक है, चार्ज कैरियर्स का फ्लो मुश्किल होता जाएगा जब ज्यादा लेंथ होगी. एरिया कांस्टेंट है, एरिया को अभी हमने पैरामीटर को कांस्टेंट रखा हुआ है, राइट? The resistance here is directly proportional to the length of the conductor. So R is proportional to L, and you can see here that by all means, since the length of the second wire is greater than the first wire, the resistance of wire 2 is greater than the resistance of wire 1, hence of its greater length. Okay? Because of its greater length. Because of its, right? तो आप यहाँ पे देख सकते हैं कि R2 is greater than R1, and also R is proportional to the length. And by all means, you also know that अगर आप potential difference को consider करें तो potential difference is proportional to the resistance, provided that the current is constant. So if R is proportional to L, then V should also be proportional to the length. ये हम आगे जाके DC सर्किट्स में भी देखेंगे कि लेंथ बढ़ती जाती है कंडक्टर की, तो उसके क्रॉस पोटेंशियल डिफरेंस भी बढ़ता जाता है क्योंकि रेजिस्टेंस बढ़ता जा रहा है. This was when the area of cross section is the same. What if we have same lengths but different cross sectional areas? Now what's going to happen is that, for example, you have here a wire like this. The area of this wire is, I call this A1. The resistance is R1. The length is L. There's another wire whose length is the same. However, the area is lesser. And this is R2, and let's say the area is A2, and this length is L. If you consider the flow of charge carriers, the flow of charge carriers in larger wire would be much easier. ठीक है, आराम से वो चार्ज कैरियर्स मूव करेंगे. अगर आप वाटर का पाइप लें, ठीक है, वाटर के पाइप भी देखें तो जो पाइप ज्यादा ज्यादा एरिया वाला होगा तो उसमें से आराम से पानी फ्लो करेगा, और जो पाइप जो है वो नैरो होगा तो उसमें पाइप से रेजिस्टेंस के साथ फ्लो करेगा. इसी तरह से जो रेजिस्टेंस है वो R2 का ज्यादा है कंपेयर टू R1. ठीक है, the resistance of R2 is greater than R1 because of its smaller area. The charge carriers would have a hard time to flow in that, right? There would be more collisions as well. So the resistance here is inversely proportional to the cross-sectional area. So by all means, R2 will be greater than R1. And you've already seen that R is proportional to 1 over A. So R is inversely proportional to the cross-sectional area, right? So which one has a greater resistance among both of these? R2 would have a greater resistance. So R2 is greater than R1 since it has a smaller cross-sectional area but the same length. This leads us, both of these results of length and cross-sectional area leads us to the concept of resistivity, right? We'll be talking about the concept of resistivity now. So, as I've already told you, that the resistance is directly proportional to the length and inversely proportional to the area of cross section. And R is proportional to L over A. And by all means, this goes like this. R divided by L over A is equal to a constant. ठीक है? तो ये जो कांस्टेंट आपको नजर आ रहा है, इसको हम कहते हैं रेजिस्टिविटी कांस्टेंट. देखिए ये हो जाएगा R is equal to this constant multiplied by L over A. इस कांस्टेंट को हम कहते हैं rho, which is the resistivity constant. This is the resistivity, right? So the formula here by all means becomes what? R is equal to rho L over A, where R is the resistance in ohms, rho is the resistivity, and I'm going to tell you the SI units in a while. This L is the length in meter, and area is in meter square. So what are the SI units for resistivity? The easiest way to find the SI units is to make that the subject. We'll make rho the subject. This is RA over L. You know that R is in ohm, area is in meter square, length is in meter. This will cancel with this one. And you'll get what? Ohm meter. So the SI unit for the resistivity will be ohm meter, right? You should also know that for the same type of materials, the resistivity is the same. For example, all gold wires will have the same resistivity, all copper wires will have the same resistivity, right? They're the same. Sometimes the question will be based in such a way that they'll be asking you that the resistance is doubled, the length is, uh, you know, increased 3 times. Okay? For example, we have rho is equal to rho if you have a same material with whose length is doubled, whose area is halved, इस तरह से. So what you can do is you can already write here R1 A1 over L1 is equal to R2 A2 over L2. This is a very important formula which will be used in a lot of questions. और आपको ये भी पता होना चाहिए कि कुछ क्वेश्चंस में वो कहेगा कि वॉल्यूम सेम है, लेंथ को डबल कर दिया तो आपको पता होना चाहिए एरिया हाफ हो जाएगा. वॉल्यूम होता है एरिया इनटू लेंथ. तो जब वो आपसे कहेगा कि वॉल्यूम वायर का सेम है, एरिया को 3 टाइम्स इंक्रीज कर दिया तो लेंथ क्या होगी? 3 टाइम्स कम हो जाएगी. तो ये चीजें आप लोगों को ख्याल रखनी है, ठीक है? क्वेश्चंस में आती है. अगर वॉल्यूम इस तरह से है, वॉल्यूम इज एरिया इनटू एल, so if the area is halved, the volume is the same, then the length would be doubled, right? तो इस तरह के बड़े क्वेश्चंस आएंगे आप. Also you should know that the equation I is equal to A and VQ will always be incorporated in many of the questions. ये भी इक्वेशन कहीं ना कहीं यूज होगी, ये आपके ज़हन में होनी चाहिए. ड्रिफ्ट करंट, क्रॉस सेक्शनल एरिया, नंबर डेंसिटी, ठीक है, ड्रिफ्ट स्पीड, और आपके पास एलिमेंट्री चार्ज यहाँ पे, राइट? Okay, so if you have a wire, N is the number density of the charge carriers. If you have a wire of diameter D, wire of diameter D is there, the length is L. The question is find the resistance of the wire in terms of rho and d and length L. तो क्या expression किस तरह से निकालेंगे जी everyone? In terms of rho, d and L, you have the formula. It's a cross sectional area, or it's a circular cross sectional area. The resistance is R, that is equal to rho L over A, and you know that its area is pi d over 2 whole square, which is pi d square over 4. And what you can do is you can always write here rho L, area की जगह आ जाएगा pi d square over 4, and the resistance is going to be 4 rho L pi d square. This is the resistance of. We'll talk about how to add resistance in series and parallel, but we will prove that in Kirchhoff's laws in DC circuits. Okay? We'll do that in DC circuits, how to prove that. But since the questions here in this chapter are about adding resistance in series and parallel, so let us discuss about that first. अच्छा जी, अगर आपके पास एक सीरीज सर्किट है, तो जो सीरीज सर्किट होता है उसका मतलब है कि देयर इज नो डिवीजन ऑफ करंट. सो रेजिस्टेंस इन सीरीज, राइट? If you talk about resistance in series, let's say I have a resistor here and I have a resistor here and we have a resistor here, and for example it goes on like this and like this. Is this a series resistor or a parallel resistor? It's a series resistor. Why it is a series resistor, a series circuit? ये आपके पास, is this a series circuit or a parallel circuit? It's a series circuit. The reason is that this is R1, this is R2, R3, R4, R5, and what's happening is that the current is not splitting here. Current split नहीं हो रहा. ठीक है, आप simply resistances को add कर सकते हैं. You should know that the total resistance in a series circuit is the sum of individual resistors. Total resistance in a series circuit is the sum of the individual resistors, right? You can simply add the resistances like this. R is equal to R1 plus R2 plus R3 plus R4 plus R5. Okay? The total resistance in a series circuit is always greater than the largest of individual resistors. मतलब जो सबसे बड़ा resistor होगा, largest of individual resistors. इसका मतलब ये है कि जो सबसे बड़ा resistor होगा ना, जैसे ये सारे resistors हैं, इसमें से सबसे बड़ा एक 500 ओम का resistor है, तो total resistance हमेशा उससे बड़ा ही होगा क्योंकि आप चीजों को add कर रहे हैं. Is that clear? So if there are n resistors are there, what you'll do is you will just simply add R1 plus R2 plus R. Simply add up all the resistors have, right? If the resistance in parallel is involved, and let's talk about that. You have resistors in parallel. And what happens is that, for example, we have here a resistor like this, and we have a parallel combination. ठीक है, जिसको हम लोग चाहते हैं कि we want कि we attain this sort of scenario, right? So what's happening is that you can see here that these are the resistors in parallel. And what's happening is, let's say there is a current I, and this is a junction here, right? And what happens is that this current splits. This is I1, this is I2, this is I3. This resistor is R1, this resistor is R2, this resistor is R3. There is an important thing here that in parallel circuits, the potential difference is the same between 2 points, across these 2 points. Let's say this is point A, let's say this is point B. So the potential difference across all of these resistors is the same. The potential difference is the same across all of these resistors. Whenever you have a parallel circuit, you have to see that the current splits. And we'll see this in Kirchhoff's laws in DC circuits as well. And there I'll prove that. So what happens is that we have the total resistance. Let's say the total resistance is R. This is the total resistance. You should know by all means that the total resistance 1 over R is equal to 1 over R1. And we'll prove this formula in the next chapter by using Kirchhoff's laws plus 1 over R2 plus 1 over R3 अगर 3 resistors हैं दोबारा लिख देता हूँ यहाँ पे plus 1 over R3. But if we have n resistors, then the total resistance is given by 1 over R is equal to 1 over R1, it's 1 over R2 plus 1 over Rn. If you have n resistors, and at the end, if you need to find the total resistance, that can be found by taking the reciprocal of entire expression. Or you can write it like this. Raised to the power minus 1. You calculate it and you know calculate it like this. So this is how you will find the resistance in parallel, and in series you simply add all the individual resistors, right? Is that clear, everyone?
Yes, sir.
Remember that in a parallel circuit, the total resistance is always less than the smallest of individual resistors. देखिए इसका मतलब ये है that if two resistors of 5 ohm and 7 ohm are in parallel, the total resistance is lesser than the smallest resistance, that is of lesser than 5 ohms. ठीक है, अगर आपके पास 5 ओम और 7 ओम का है तो आप कैसे निकालेंगे 1 over 5 plus 1 over 7, और आपके पास जो आंसर आएगा you'll take the LCM. This is 35, right? This is 7 plus 5. This is 1 over R, and you can cross multiply or take the reciprocal. 35 over 12. What is the answer for this?
Sir, 2.9.
So you see that it is smaller than the smallest resistance. Right? It is smaller than the smallest of all the resistors in parallel, right? Remember that. So we have here, find the total resistance between X and Y, where we have something of this sort. We have here a junction. This is a resistor here. Let's say this is 5 ohms. Let's say we have another resistor here. And let's say this is 7 ohms. Let's say we have another resistor here. This is 8 ohms. We have 4 ohms here. And we have here another resistor which is 8 ohms. let's say this point is x, let's say this point is y. आपके पास ये x और y के दरमियान रेजिस्टेंस क्या आना चाहिए? जब इस तरह का क्वेश्चन आ जाए तो how do you approach this problem? This is 5, this is 7, and we have here 8, we have here 4, and we get what? We get 8 here, like this. So this is going to be what? This is going to be 12 here, and this is also 12, right? And you get this 8 in series with this combination. ये वाला जो combination है, इसको जब आप solve करेंगे, this combination as you do 1 over r is equal to 1 over 12 plus 1 over 12. And once you do the maths, this is going to be 2 over 12. This r is 6 ohms. What you get is that you get 6 ohms here and you get 8 ohms here. And you get what? 6 plus 8 as 14 ohms. Because this 6 and this 8 is what we call, 14 ohms. So this is how you approach such questions, right?